Hi, this is Chris and Barrett. We're going to give a quick demonstration here of our tool Invoke-UserSimulator, which will simulate some common user behaviors on your lab environment. So the first scenario we're going to go through is running the tool locally on just a local VM that we have set up here. So all you got to do is import module on the script and then run the Invoke-UserSimulator function with the standalone flag, and that'll tell it that you're just running it on your local system. And then we're going to give it the shares flag to tell it to only do the share mapping function, because that's what we want to show locally here. Alright, so when that runs, what it's doing now is randomly generating a share name and attempting to map it. So what that's going to do is, since the share name is randomly generated, the computer does not know what resource that is, and it needs to send out a broadcast request to the local subnet asking if anyone else knows what the resource we're looking for is. So by using a tool like Responder, what an attacker can do is sniff that traffic on the network, respond to the requests, and then get the authentication from our local computer there. So all these big yellow blobs that you see are the net NTLM v2 hashes that our local machine running the tool is sending out based on these responder responses.
Yep, and you can also see the randomly generated share names in here, and we just happened to start Responder right before it sent a random one, but it'll wait another 30 seconds or a minute, whatever the default is, before it does it again. Looks like 30 seconds.
Alright, so that's the local version. It's pretty easy, you don't need admin or anything. The other scenario that we're going to run it in is remotely. So if you have a dedicated lab environment and you want to run this, simulate users on multiple hosts at the same time, it's kind of a pain to log into each one of them and run it locally. So you can give it a config XML flag and provide it this document, which has the details for each user and host that you want to simulate, and also the IP of the server that you're running it from, and some other configuration details for the individual functions, like how long between share mapping and how long between checking for new emails. So same process to load up the script, and then we're going to invoke the configure host function first, and what that's going to do for us is set some registry keys so that Outlook is allowed to access mail programmatically, and also if the user is a first-time user on the host that you're running it on, it'll skip the Internet Explorer prompts. It also adds the user to the remote desktop group so that we can actually remote in.
And you'll see here, we can see adding 3 registry keys there, and also we've got an error that the account name is already a member of that remote desktop group. So we've run this before on these hosts, so it'll just error out, but no big deal.
Alright, so the next thing we're going to do is invoke User-Simulator function. We're going to give it that same configuration XML file as input, and then so you can run the functions individually. So like with the local system, we did shares, and you can also do IE or email flags to individually run those functions, or you can give it just a -all and it's going to do all 3. So we're going to go ahead and give that a go. And then what you see happening on the screen now is first our tool creates a scheduled task on the remote host that should launch our tool with the configured options that we gave it whenever a user signs into the system. We then create remote desktop sessions on those hosts with those users so that the scheduled task runs, and then our tool is going to do the internet browsing, share mapping, and email all in the actual interactive session of the users that we have configured. So we'll just let those connect and for everything to get going, and hopefully we should see some Internet Explorer pop up.
The tool does not close these remote desktop sessions, but you could certainly close them all or do a stop process on the MSTSC process and close them all at once.
So it looks like we have our Internet Explorer window opened up. So it went to espn.com. It's then going to spider that page for additional links and just browse to those links until it reaches the link depth that we have in the config XML. The next thing we can do real quick is to run a little phishing campaign. So our email function should automatically open emails and any attachments inside of them, and also execute any macros that we have inside of those attachments. So if we send our pre-configured malicious Word document here, we should be able to have the tool open up those emails for the users we have configured, grab the attachment, save it to a trusted location, a trusted directory on the system, and then open it from that directory. And opening it specifically from those trusted locations is going to allow us to bypass any prompts to enable and run macros. So our malicious macro should hopefully run automatically, and then we'll see those command and control channels come back on our C2 server. And we're using Cobalt Strike for this. So we'll show you that in a second.
Send that, and we've got Cobalt Strike up here with no beacons yet. If we keep an eye on these remote desktops, you will see Word open when it goes to run that macro.
So usually the phishing stuff takes a little while. So what the script is doing is every minute it checks in and does a send receive, and then it waits for a minute for any new mail to come in for the mail server. And that minute wait is just to allow for, slow networks or whatever mail server issues might be happening.
Big attachments, whatever it
Yeah.
is.
Allows any new mail to come in and not error out on you, so you know what's going on. Then after the mail comes in, it'll parse the mail for attachments and links, open up any links, and open up any attachments.
So we should have a maximum 2-minute wait here, is the moral of that story. Ah, I can see Word coming up over here. Boom, and we have a beacon. Should have 3 more of those rolling in soon enough.
Alright, there's another one.
So this will finish at whatever pace it finishes here, but that's all the functionality of the tool. Thanks for checking it out. Go grab it on GitHub and try it out yourself in your lab.